Hello everyone, in this video we'll learn about mod type examples. So let's construct a DFSM initially for the set of string over a comma b such that length of w mod 2 is equal to 0. Let me write the question. So I'm going to explain here mod type example. So I'm going to construct a DFA, for the set of string over a comma b such that length of the string w is divisible by 2. Length of a string w is divisible by 2. That is length of w mod 2 is equal to 0. The same problem, this problem can be asked even this way. So as usual, let's list the strings that can come in this language. So those are empty. Since length of mod 2 is 0, string here is length 0. Okay, so mod 2 is 0. Next AA, AB, BA, BB, then AAA, and so on. Now let's construct a DFSM. So here the length of mod 2 is equal to 0. Here you can observe, if I supply this string to a machine, isn't it? If I supply, this is a machine DFSM, if I supply AA, it should accept. Whereas if I supply AAB, it should reject. It should not accept. So that means it should reject. Now, since the language contains epsilon, one thing you can note. So since the language contains epsilon, so first of all, the start state itself you can make as double circle, that is accepting string. So empty string should be accepted. That means without reading any input, it should accept. That means only the option is for this is making start state as accepting state. Next, suppose if I pass AA. So since this is an accepting state, okay, A, one more state I will take B. A, it should go, and then A and A, it should accept this way. Now suppose if I take BA, so B here it should go, and then B, A, it will okay. Now if I take A, B, so here it should take B. So A, fine, it will accept at this particular state. When the string ends, it will be an accepting state. B and then A, okay. B, B. Okay, now let's try A, A, B. What the machine should do? Reject. Reject means it should land in, finally at the end of the string it should land in non-accepting state A, and then B. It will come to the state A here, then B. It should start from B, then one more character A, and then B. I want to check A, B. First first character A, I land at B state, then next character I will read B, so come back, next A, I come to B state, after reading A I come to A state, after reading B I will come to B, this state. This is a non-final state. Obviously this particular length of this this particular string's length is odd, so it is not divisible by 2. So length of the string mod 2 is here is 1, not 0. Okay, this is the machine. So let's construct a quintuple. M is nothing but set of state A comma B, Q sigma. Sigma is alphabet in the sense these alphabet. What are the strings containing alphabet A and B? So that is in the transition. Sigma delta S is the start state, then the S is the start state and the final state S is S in the sense this start state. You have to write your start state, and finally you have to write accepting state. Accepting here is state is this state. So I have written. Next we'll write where delta equal to where delta equal to A, B. Sorry, states here it should be A and here it should be B. State bar input. A on A goes to B state, A on B goes to B state, and B on A goes to A state, B on B goes to A state. So this is for this particular input, this particular language. Okay, now we'll see another example. Let's construct a DFSM for the language length of W mod 3 equal to 0, where W belongs to A comma B star. So now first we'll write the language that can come in the language. Since it is length of W mod 3 is 0, so epsilon can come because length of the string is 0. So 0 mod 3 is 0. Next A, B, B, and so on. There are so many. Okay. Now, how to construct a language? How to construct a DFSM? So here note that length of W mod 3 equal to 0. So the reminders here are for mod 3 0, 1, 2. So you need to have 3 states. In the previous case, we had only 2 states as the reminders for mod 2 was 0 and 1, only 2 states. So here also, let's construct a states. How many states? 3 states. One representing the reminder 0, one another representing reminder 1 and one more representing reminder 2. Okay. So this is the start state, and start state has to become an accepting state as the language contains an epsilon, because without consuming any input it should accept. Okay. Now let me name the state as Q0, Q1 and Q2. Upon reading A, 3 A's. Let me take 3 A's. What happens? 3 A's means length of the string is 3. 1A it will go here. Second A, then as length of the string 2A. Okay. Then when it is 1A, the remainder is length of the string is, when there is only 1A in the string, length of the string is 1. So 1 mod 3 is 1. So it should come to this state. Okay. So this Q0 representing mod reminder 0. Okay. Q1 representing reminder 1. Q2 representing reminder 2. So now when A is 2, okay, it goes to Q2. When A is third A, it should come back to Q2 as the reminder. In 3A, if the string is 3A, then the length would be 3. 3 mod 3 is 0. If there are 6 A's, then 1A, second A, third A, fourth A, fifth A, sixth A. So A's will traverse like this. Finally, it will land in Q0. Okay. Now if there is B, again same way. Let's suppose let's consider 3 B's. 1B, 2B, 3B. So it should go in the same manner. So this is a DFSM for the length of string mod 3 is equal to 0. Now I'll write a quintuple. M is equal to how many state? Q0, Q1, Q2. Initially Q is nothing but set of n sigma. Sigma is nothing but string containing only 2 characters, A, B, delta. Start state is Q0 and final state is also Q0. Okay. Now delta, where delta equal to Q0 on A goes to Q1, comma Q0 on B goes to Q1. Next Q1 on A goes to Q2, comma Q1 on B goes to Q2. Then Q2 on A goes to Q0, comma Q2 on B goes to Q0. So this is the transition relation. And remember, suppose the question is given like length of mod 3 is equal to 1. In that case, how are you going to change this DFSM? Just make, since length of mod 3 equal to 1, that means the remainder it is expecting 1. So you have to make Q1 as the accepting state. Whereas here, why did we make Q0 as accepting state? The length of string mod 3 is equal to 0. When you want mod 1, that is mod 3 equal to 1, you have to make Q1 as an accepting state. Similarly, if you want length of mod 3 equal to 2, then you have to make Q2 as an accepting state. Let's consider one more example related to mod type. We'll design a DFSM for the language L equal to W belongs to A comma B star such that number of A in a string mod 3 is equal to 1 and number of B in string mod 2 is equal to 0. This is the question. Okay, we need to, the language need to achieve this constraint, and the same thing, this constraint can also be written in this way: number of A in string mod 3 equal to 1 and number of B's in a string mod 2 equal to 0. How to design a DFSM for the language? This kind of a language. So let me write the language first of all, which can contain a string like number of A's has to be at least 1A. So this can be accepted where the number of B's are 0. Then A, then so this kind of, see, if you count here, then this, if you supply this kind of a string to a machine, the number of A's in a string is 4, number of A's in a string is 4, number of B's in a string is 1. So 4 percentage 3 is 1, 1 percentage that 1 percentage 3 is 1. So 1 percentage 2 is 1. So we cannot accept that. So there has to be one more B to satisfy this constraint. So number of A's are 4 and number of B's are 2. So this kind of a string can be accepted. So these are the some of the strings. Now let's see the states. What are the number of states this should contain? Because as the constraints are 2, that is 2 criteria we have to satisfy: mod 3 equal to 1 and mod 2 equal to 0. For that case, the number of reminders for mod 3 are 0 and 1, 2. So reminders for mod 3 are 0, 1, 2, and whereas for mod 2 it is 0, 1. 0, 1. So now the reminders for mod 3 are 0, 1, 2. Reminders for mod 2 are 0, 1. So the number of states would be the combinations of 0, 1, 2 cross 0, 1. That means you will have the states for first element from this. Let's take 0 and the first element from this. First element from this and then the second element of this 0, 1. Similarly 1, 0, 1, 1 and then 2, 0, 2, 1. So how many we get here? The combinations we get here are 6. So total, so therefore total will have 6 states. Total will have 6 states. So let me write the states. So the states I am going to consider here are Q00, 00 and Q01, Q10, Q11. You can observe here. Then Q20, Q21. So here what does Q00 indicate? That is mod 3 is equal to 0. So number of A's of string mod 2, the first one says mod 3 remainder would be 0. Second one says, subscript says that it is mod 2. This is with reference to mod 3. This is with reference to mod 2. Similarly, with the first character is with reference to mod 3. This will be the remainder of mod 3 is number of A's in string mod 3 is 0. Number of B's in string mod 2 is 1. Similarly, this also goes. Number of A's in string mod 3 here is 1, and this 0 is representing number of B's in string mod 2 is 0. Similarly, the next state is indication for the strings. Number of A's in string mod 3 is 1 and number of B's in string mod 2 is 1. Similarly, 2 0 and 2 1. Okay, so let's write now the states. Q0 0, Q0 1. The start state will be Q0 0, Q1 0, Q1 1. Next Q20, Q21. Now Q20 and Q21. So now number of A's in string mod 3 is equal to 1 and number of B's in string mod 2 is 0. So we want the remainder 1 and remainder 0 based on mod 2 and mod 3 and mod 2 respectively. So that means accepting the state need to be this, because the first subscripts represent what? Mod 3 is 1, second one says mod 2 is 0. So this one need to be an accepting state, okay, for this particular problem. Now let's give a input and see. Initially, when you are in the Q00 state, okay, initially when you start, number of A's and number of B's are 0. Number of A's and number of B's are 0. When you give A, okay, when you give A, what happens? Number of, that is just the input A. Here number of B is 0, number of B is 0. So A is 1, B is 0, percentage 3. B here is 1, percentage 3 here is 0. So that means you should go to which state? Which state? Q10 state, because already we have told A can belong to the language. Next Q00, if it reads B, just B, single B, when you are in the start state, if you get just B, what happens? So you know that in the DFSM all states should take transition on all the characters of alphabet. So you know that sigma is here A comma B. For A, we have already done a transition B. So if the only B we pass, what happens? Number of A is 0, number of B is 1. So percentage 3 and percentage 2. What is this? 0 percentage 3 is 0, 1 percentage 2 is 1. So it should go to the state this. Okay. It should go to the state Q01. Next, when you are for Q00, for both the characters, it has taken a transition. Let's imagine now you are in Q01. So you know that when you reached Q01, you have already taken a transition on character B. Now if you get A, what happens now? If you get A, so number of, that is at Q01, if you get A, because to reach Q01 you have taken a transition on B. So number of B is a permanent character. If you take A, what happens? So that means right now the number of B is 1, number of A is 1. In that case 1 percentage 3 and 1 percentage 2, that will give you 1 state Q11. So now A. Next, when you are in Q01, if you get B again. So after getting B, when you are in a Q01 means you have read B. Now again if you get a character B, what happens? So number of B's are 2. 2 whereas number of A's are 0. Number of A's are 0. 0% 0 is 0. 2% 2 is 0. So you have to go back to Q00 state. Q00 state. So, sorry, on B. Now, when you are in Q10, what do you mean by when you are in Q0? Q10 means you have already read the character A. You have already read the character A. At Q10, you have to take a transition on A character and then B character. So as I said, when you are in a Q10, you have already read the character A. Next you can take is either A or B. So let's check for A. So in this case what happens? Number of A's are 2. 2% 3 is 2. Whereas number of B's are 0. 0% 2 is 0. So Q2 0. So you have to go here. Next, when you are in Q10, if you read B like this, after reading A, if you get B, so number of A's are 1, B is 1, 1% 3, 1% 2, it is 1, 1. So you go to this state. Next, when you are in, so Q10 has already taken a transition on A and B, so it's done. Now Q11. So coming to Q1 on now when you are in Q11, it is already number of states are 1 and here also 1, right? So you can observe, if you see this path, there is BA. You can choose any one path, whichever starts from start state. Okay. Now on Q11, if you after BA, if you read A, what happens? Number of A's are 2. Number of B is 1. So 2% 3. So number of A's mod 3 you have to do. So for number of B's mod 2 you have to do. So 2% 3 is 2 and this is 1. 1% 2 is 1. So if you are in Q1 and if you have read the character A, you should go to the state Q21. Okay, Q21. Next Q1 on B. So when let's again I will consider this path. As I said, any one path from start state you have to consider. Next BA. After reading A, BA, you will come to Q1 state. Now if you for A character you have already taken a transition. Now I'll check for B character. Number of B's here are 2. Number of A's are 1. So 1% 3, 2% 2. 2% 2 is 0 and 1% 3 is 1. So you have to go to the state Q10. So on from Q1 on B character you have to go to Q10. Okay, this is done. Next, for this state is done. Now we'll see for Q20. When you are in Q20 state, which character you must have read? So let me consider the one path that starts from start state till Q20. This path I will consider. So A. Now after reaching Q2 before reaching Q2 0, you must have read these two characters. Now upon reading a character, what happens? Number of A's are 3, number of B's here is 0. So 3% 3 and 0% 2. 3%. See, this is one path I am considering. You can get any other path which mixes, which is having A's and B's combination. Okay. 3% 3 is 0, 0% 2 is 0. So from Q to 0, if you are taking a transition on a character, then you must reach to Q00 state. Q00 state. So it is like this. Okay. Next, coming to Q21. Coming to Q20, as I said earlier, I will consider this path, and so before reaching Q20, you must have read a character. Now I want to see what happens if I read the next B character. So number of A's are 2, number of B's are 1, 2% 3 and 1% 2. What it is going to give? 2% 3 is 2, 1% 2 is 1. So from Q to 0 you should reach, if you are reading B character, you should reach Q to 1. Okay. Now at the end, the last one state is left for checking transition on A and B character. Q to 1 on. So to reach here, what character you must have read? You have several paths from start state to here. I will consider this possible path. It is this path I will consider. There are even this path you can consider. So I will consider, okay, this path I will consider. It is, this way. So before reaching here, it must have read BAA. BAA. So number of B's here is 1. Number of A's here is 2. Number of B here is 1. Number of A is 1. Number of A is 2. Number of B is 1. Okay. Now 2% 3 if you do, what you will get? 2. 1% 2 if you do, what you will get? 1. So the state would be, upon reading character A from Q to 1, okay, I did not take. So till Q to 1 you must have read A. Then after that you have to consider upon reading A character. That means one more extra A's we will have. So 3% 3 is 0 and 1% 2 is 1. Number of B is 1. Number of 3 here becomes, number of A's it becomes after reading A 3, not 2, and number of B's will be 1. So 3% 3 is 0 and 1% 2 is 1. So from Q to 1 you must take a transition to, on A character you must take a transition to Q01. Now let's see the transition on Q21 state for B character. So as I consider, so again till here, till Q21 you must have read BAA. So let me take the same example, and upon reading B characters, what happens? Number of A's would be 2 and number of B's would be 2. So percentage 3 and percentage 2, what value it is going to give? 2 and 0. So the state from Q to 1 on reading B character, you have to go back to Q to 0. You have to go back to Q to 0. So this is the final DFSM for the problem number of A's in string W, number of A's in string mod 3 is equal to 1 and number of B's in string mod 2 equal to 0. So this is the final answer. So let's write now quintuple. M is nothing but Q sigma delta S comma A. Let's write this. Q is nothing but set of states. How many states we have? Q00, Q01, Q10, Q11, Q20, Q21. And sigma is nothing but only two character A and B. Then delta is nothing but the transition function. Let's write in the table format later. Delta S comma A. What is the start state? Start state is Q00 and final state is Q10. Q10. Now where delta is nothing but Q00, Q01, Q10, Q11, Q20 and Q21. These are states. Rows will represent states and the columns will represent the input characters. Now Q00 on A goes to Q10. Q0 on A goes to Q on B goes to Q01. Then Q01 on A goes to Q11. On B goes to Q01 on B goes to Q00. Then Q10 on A goes to Q20. Then Q10 on B goes to Q11. Then Q11 on A goes to Q21. Q11 on B goes to Q10. Then Q20 on A goes to Q00. Q20 on A goes to Q00. You can check this one. Sorry, Q200. Instead of writing A, I wrote 0. Q20 on A goes to Q00. Q00. Q20 on B goes to Q21. Q21. Then Q20 on B goes to Q21. Q21 on A goes to Q01. Q21 on B goes to Q20. So this is the transition table. Now we'll see another problem to design a deterministic DFSM for the language where sigma equal to A, B such that the language contains a string where the length of W mod 3 is greater than length of W mod 2. So this is same as the previous one. So length of W mod 3, that means which has to be greater than the length of W mod 2. As I said earlier in the previous example, here also you need to find the reminders for mod 3 and mod 2. So reminders for mod 3 are for mod 3 if you consider 0, 1 and 2. Mod 2 if you consider it is 0, 1. So these are the reminders. Now here as usual, since there are two conditions, the states for the number of states will be 6, like a number of in this remainder is 3 cross 2, that is equal to 6. Which are the states representing mod 3 0 0 remainder, okay, like previous case 0 1 comma 2, we have to make a combination with 0 comma 1. So therefore the states are same thing like previous, q00, q01, q01, 10, q11, q10, q11, q20, q21. These are the states. Okay. Once after deciding the states, you have to decide now which can be the accepting states. So the construction of a DFSM is similar to the above. So let me construct that DFSM which containing all these states. Let me construct that again. Start state starts from here. Start state starts from here. Okay. Okay. Now here number of w's, the length of the string mod 3 is greater than this. So here in which subscript, see this first subscript represents the mod 3 and the second one represent mod 2. Okay. So the accepting states, this first character need to be greater than the second character. In this no, in this yes. So accepting states can be q10, then q11 is equal, both are equal, whereas in this case 2 is greater than, that's what we want, length of w mod 3 greater than length of w mod 2. So 2 is greater than 0, so it is q20, and then next q21. Only these can be here accepting state. q10, this need to be double circled, q20, and then q21. Let me pass a string now. If it is a, suppose the string is just a single character from a state, because when you supply a, let's assume at q00, the length of the string is 0. Length of the string is 0. Suppose if you pass a, suppose if you pass just a character a, then what happens? The length of that string a is 1. 1% 3 is 1 and 1% 2 is 1. So if you read a character, so you have to go to which character state, that is q1. Let me change this as q11 and here it is Q1 0. So on reading A character, it will go here. Okay. So you can write the state anyhow. So for my convenience, I will change this as Q11 and this as Q10. As per your convenience, you can change it. Okay. Now Q00 on A, reading A, it will go to Q11 state. Q11 state. Now in the beginning, if you read just single character B, length of B is 1. So string is 1, A comma B, it will go to the same state. So 1% 3 and 1% 2 is 1. Next, uh, at Q0 has taken a transition on both characters A and B. Now we'll see about the next state from Q11. Q11, you've already read either a character A, either one character, let's take that is A. Okay, at Q11, you have already taken one character A. In that case, what to do? That is, when you have reached here, reaching here means you have already read at least single character. Okay, single character you have read. At Q1, reading one more character means the length of the string is 2. Length of the string is 2. So 2% 3 will be 2% 3 will be 2 and 2% 2 will be 0. 2% 2 will be 0. So upon reading a character A, it will give you the state Q20. 20. Okay, you have to go to state A. Now when you are here, you will be reading just a single character. Suppose if you read one more character B, the length of that string will be 2. So as usual, 2% 3 will be equal to 2 and 2% 2 equal to 0. It will take you to Q20 state. Okay. Now when you have reached Q20, you have read already 2 characters. Now after this, if you read one more character, where you are going to reach. So let's imagine when you have reached here means you have already read 2 characters. Okay, you have read 2 characters. It can be AB or it can be AA, it can be EA or BB, whatever. So after that, if you read one more character, it may be ABA or ABB. Length of that would be 3. Length of that will be 3. So 3% 3 or 3% 2, whatever may be the character. So it is going to give you this kind of option. 3% 3 is 0. 3% 2 is 1. So you have to go to the state. So after reading Q20, you have to go to the state Q01. Q01. So I will change here Q21 to Q01. So whether you read A or B, you will go to the state Q01. Okay, you will reach Q01. At the end, I will make a final state. So I feel that is better. So I know what are the accepting states. Okay. Now after reading Q0, after reaching Q01, you have read 3 characters. It means you have read 3 characters. It can be any combination of A and B. So if upon reading one more character, the length would be 4. So 4% 3 and 4% 2 will give you the state, that is 4% 3 is 1 and then 4% 2 is 0. So 1 0. So upon reading A comma B, you are going to get this state. Next, from Q10, you have read 4 characters. So reading one more character is length will be 5. So 5% 3 you are going to get 2 5% 3 and 5% 2, you're going to get 2 0 and 2 1. Q 2 1. So the state will be, finally you will be reaching Q 2 1. So let me change this, so it is Q21. So upon reading fifth character, you land in Q21 state. Now after reading the fifth character, if you read one more character, it can be A or B. The length of the string will be 6. So 6% 3 will be 0 and 6% 2 will be 0. So you will reach to Q00 state. So from here again you are back to Q0 state. Whether you read A or B, the length of the string will be 6. So you will reach to Q66, Q00 state. Okay. So this is about the DFSM. Now we have to draw the final state. As earlier I told, Q10, Q20, Q21, you should make it as final state. Q10 is, where is it? It's here. It's here. Q20 is here. Then Q21 is here. So these will be the final state. These will be the final state. So for this, we can construct a quintuple. Like before. So M is equal to K sigma delta S comma A. So states are like before: Q0, Q01, Q10, Q11, Q20 and Q21. So these are the states. Then sigma is A comma B. Sigma is A comma B. Delta is a transition relation. Then start state is Q00. You start from the empty string. Then final states are 3, which are those: Q10, Q20. Final states are Q10, Q20 and Q21. Okay, these are the states where delta equal to, let me write in a table wise. A and B. So we have 3 states: Q00, Q01, Q10, Q11, Q20 and finally Q21. So Q00 on A and B goes to where? On A and B goes to Q12. Q00 on A goes to reaching 1 1. So it goes to Q11 and Q01, this is 1 1, Q01 goes to 1 0, goes to 1 0. Next Q10 goes to on A Q21. Q21. Next Q11 on A. Q11 on A goes to Q20 as well as B. Q20. Q20 on A goes to Q20 on A goes to Q01. Q01 and then Q21 on A and B goes to Q00. Q00. This is the transition table for DFSM. So this is about the DFSM for the languages over sigma equal to a comma b, such that length of W mod 3 greater than length of W mod